So, hi everyone, thank you all for being here. Today we're going to talk about VBS and VBS enclaves. This is a research that I've done with Ori David, my coworker who couldn't be here, and we hope that you enjoy. First, before we begin, I just want to say that I apologize to everybody who thought that this is going to be a presentation about VBS, the programming language. It's actually not. It's about VBS, the new security mechanism by Microsoft. I see that all of you are staying here, so that's great. My name is Tomer. I am a security and vulnerability researcher at Akamai Security Group. I am a gamer. I am a new father to baby Leah, who is 1 year old, and you can find my other resources on the GitHub link that's on the slide right now. Our agenda for today is that we're first going to talk about VBS, then we're going to talk about VBS enclaves, and then we're going to talk about the actual fun part of how to abuse those VBS enclaves. So let's begin. In the past, Microsoft used to rely on the ring 3 to ring 0 security boundary. But this proved to be very ineffective. And that's because a lot of attackers and other researchers found a lot of exploits around the security boundary. And moreover, attackers found out that they can actually bring their own vulnerable driver in order to bypass the security boundary. So a solution had to be created. And this leads us to Hyper-V. One of the core functionalities of Hyper-V or hypervisor is the ability to isolate one VM from another one. So in the example that you can see on the screen, VM1 will not be able to read or write anything from VM2, and vice versa. VM2 will not be able to read or write anything from VM1. The same thing can also be said about the operating system. This is because from Windows 11 and onward, every Windows is running above Hyper-V. And this means that we can create an isolated part of the operating system that the operating system itself will not be able to access. This creates a new security boundary that Microsoft called VBS, or virtualization-based security. In order to implement this new security boundary, Microsoft has also renamed their ring 3 and ring 0 into VTL. So in normal Windows operations before VBS, in ring 3, we will have the user mode, and in ring 0, we will have the kernel mode. This will be called VTL0 with VBS. Now, with VBS, we will also have VTL1. VTL1 will contain the secure kernel mode, and more interestingly for us today is the isolated user mode. It's more interesting for us because enclaves will run inside the isolated user mode. Since VTL1 is more privileged than VTL0, nothing from VTL0 will be able to interact with VTL1, including the kernel, and the isolated user mode inside VTL1 will be able to read and write anything he wants from the kernel mode. Now that we've talked about VBS, let's talk about VBS enclaves. In much the same way that we have talked about the operating system, VBS enclaves are an isolated part of the process that the process itself will not be able to access. This sounds a little bit weird, right? Because why would we need an isolated part of the process that the process itself will not be able to access? Well, let's consider the following scenario. Let's say that an attacker gained a foothold inside a victim's endpoint. Now he will try to steal sensitive data from a process. With the advent of enclaves, the sensitive data can now be stored inside the enclave. This means that even if the attacker tries to steal the sensitive data, he will not be able to. But the process itself will still be able to use this sensitive data to authenticate with servers online and to do some other cryptographic methods and other stuff, because the process itself will still be able to invoke the enclave methods that are residing inside the enclave. Now, sorry, we just talked about it. Now let's talk about the lifecycle of enclaves. Once a process is created, it will first load NTDLL and other DLLs, and it will also load the enclave. Enclaves are usually compiled as DLL and must be signed by Microsoft. Once these enclaves are loaded into the process can now call the enclaves using special kind of enclave methods. To attackers, This can be very, very appealing because it's an isolated part of the process that EDRs cannot access. This means that attackers can place their own shellcode inside VTL1 and will be able to potentially execute it. And also, since enclaves are running inside the isolated user mode, they are using a different set of DLLs that are not being able to be hooked by EDRs. To illustrate this, let's see the following example. On the left, we can see a process that has been created, and on the right, we have an enclave inside VTL1. The process will first load NTDLL. NTDLL will be hooked by an EDR, and the EDR will be inside the kernel mode waiting for any API call from the process. Enclaves are not loading NTDLL. They will load virtDLL, which will communicate with the secure kernel. Enclaves and all API calls from the enclave will go to the secure kernel and will not be able to be hooked by EDRs. So now let's get to the fun part about how to abuse those VBS enclaves. But before we can do so, as we have said, VBS enclaves must be signed by Microsoft. This proves as a limitation for attackers. So in the next section, I want to go over 4 different options that we thought about that can bypass this limitation. The first one is by using is a pretty straightforward one, and it's by using legitimate signatures. By that I mean that attackers can use their maliciously obtained certificate in order to sign their enclaves, therefore loading it into their process. They can also use shell companies in order to obtain the privileges that they require in order to sign those certificates and sign their own enclaves. This is a good path to take for attackers, but we've not seen this in the wild yet. The next option is by exploiting the loading mechanism. Since enclaves are not widely adopted yet, since their loading mechanism has not been researched thoroughly yet. And this means that there might be some sort of exploit or vulnerability inside this loading mechanism. And actually, in 2024, Alex Ionesco has managed to find that vulnerability that can allow attackers to load their non-Microsoft signed DLL into a process. This is a great path to take also, but now I want to talk about 2 other options that I think that are more widely available to everybody. And the first one is by using debuggable enclaves. So let's say that we are developers and we want to develop our own enclave. What we would usually want to do is we will want to place breakpoints in order to debug our own code. And once we will do so, this is how it will look like. And this is because our debugger is inside VTL1 and our enclaves are inside our debugger is inside VTL0 and our enclaves are inside VTL1. This means that once our debugger tries to read anything from our enclave, it will not be able to do so. Microsoft has taken notice of that and created a flag that's, once enabled, allow for debuggers to actually communicate with enclaves inside VTL1. Once they do, once developers place a breakpoint now, they will be able to read what they want from the enclave. But this does break the isolation of enclaves, because not only can enclaves now communicate with the debugger inside VTL0, they can also communicate with every process inside VTL0, including EDRs. But the reason why we think that this is still okay is because EDRs and sorry. This is okay is because something. Okay, so what we initially thought about this is that enclaves are now running inside VTL0. This is not actually the case. Enclaves are still running inside VTL1. So how could this be implemented? Well, what we found out was that Microsoft actually implemented enclaves by implementing secure kernel exceptions. This means that now the enclave can reside inside the isolated user mode, but can communicate with every process inside VTL0. Microsoft could not have been more clear about why this is not good for production mode. And actually, when you go to their site inside MSDN, you will see the following warning. But this is not the only problem, the isolation. Because if attackers manage to obtain a debuggable enclave, they will be able to load this into their own process. They will be able to place a shellcode inside this debuggable enclave and will be able to run anything they want to inside the isolated user mode. Now, we go over this in greater detail in our blog post, but for now, I just want to highlight in high level how this process is being done. So let's say that we have a process inside VTL0, and in VTL1, we have an enclave with an enclave routine. What an attacker will first do is invoke getProc address to retrieve the starting address of the enclave routine. He will then use virtual protect in order to change the page into a execute read write. He will then place his own shellcode into overwriting the enclave routine, and finally, he will call the enclave routine, which will execute his code inside the isolated user mode. Now, there is one catch, and that is that EDRs can now also see anything from the enclave. But the reason why we thought this is still okay is because EDRs and blue teamers are not aware of this threat yet, and since enclaves are not widely adopted, they would not consider this as an attack scenario. And also, enclaves are still running inside the isolated user mode, which means that any API call that they are making will not be able to be hooked by EDRs. And finally, I just want to say that we haven't managed to actually find a debuggable enclave in the wild yet. And the reason why we thought this is okay to talk about them for the last 5 to 10 minutes is because we do think that once enclaves are widely adopted, somebody will screw up, and one of those debuggable enclave will find its way into VirusTotal or any other services online. So let's talk about our final option for today, which is to bring your own vulnerable enclave. In much the same way that attackers are currently using their own vulnerable driver, they can also use their own vulnerable enclave in order to bypass security mechanisms inside a victim's endpoint. And this seemed like a great path to take, so we did a quick Google search and we found out about this CV 2023-36880. This CV was classified as an information disclosure vulnerability inside Microsoft Edge, but once we took a deeper look into its details, we actually found out that it could lead to limited command execution. This seemed very interesting to us, so we dug a little bit deeper into it. And what we found out was that Alex Gao, who discovered this vulnerability, also shared a POC. And when we took a look at this POC, we found out that this vulnerability actually allows for an arbitrary read-write primitive into an enclave. This seemed very interesting, so we played with it quite a while, but we couldn't get any code execution. And this is because enclaves are protected by ACG, or arbitrary code guard. This means that no dynamic code can be executed during runtime, and also no pages can be turned into an executable page or a writable page. So if you try to play with it, this is the error message that you will actually see, and we figured that we need to take another path. But at this point, we were really struggling because we had a really cool primitive, and we wanted to make it work. So it leads us to round 2. And let's recap what we can actually do. Using this vulnerability, we can actually write data from VTL0 into VTL1, into the enclave. And more importantly, we can write anything that we want from VTL1 into VTL0. This writing process will not be able to be blocked because, as we have said, EDRs cannot block anything that is running inside the enclave. So after playing with this, we came up with Mirage. Mirage is a sleep obfuscation technique and tool that allows attackers to place the obfuscated code or the shellcode inside the enclave using this vulnerability. And once in a while, this code will activate, execute without the EDR noticing it, and will go back into a dormant state. Before we can see Mirage in action, I want to illustrate how it works. Let's consider the following scenario. On the left, we have Mirage inside VTL0 with a vulnerable enclave inside VTL1. Now, using Mirage, we will be able to place our shellcode into the enclave. In this stage, the EDR will not be able to see anything that there is anything wrong inside Mirage. Once in a while, the shellcode will be written back into Mirage. The code will be executed, and then will be overwritten by benign data. Again, so EDRs will not be able to catch us in the act. Now, let's see this in action. On the left, on the right, we will see Mirage, and on the left, we will be able to see its memory and a blank buffer that it will create in order to place its shellcode into. So right now, we have written our buffer and placed blank zeros in it. We zeroed it out. Okay. Now we can see our buffer is all zeroed out, and once we press continue, we will be able to see our code, our shellcode. The shellcode will execute calc without the EDRs being aware of it, and will go back into zeros. We were able to see the shellcode right now because we placed breakpoints, but in real time, we won't be able to see anything inside this buffer. Just to make it clearer, let's see this again, I think. Yeah, that's great. And calculator have been opened without the EDR noticing it. So, thank you. So let's go over the advantages of Mirage. During this sleep phase, nothing will be accessible from VTL0. The EDRs will not be able to see anything. And as we have said, the writing operation from VTL1 also will not be able to be hooked. So we have 100% chance guaranteed to execute our code. In conclusion, we just want to say that VBSs are cool and we enjoy researching them. We do see a lot of potential both for attackers and developers, but especially for attackers. So we think that you need to keep an eye on them. And that's it. Thank you very much. And you can see our blog post by using this link. Thank you.
Any questions? Going?
Yeah.
Going with Mike.
We're having going. Yeah.
Okay, so during introduction of several security features, we learned in the history that it's also important not to introduce extra attack surface. Would you consider that here introducing the extra attack surface over the benefit from it is better than just introducing extra?
I can't hear you. Can you maybe turn it up?
I'm just when you introduce new security features, it's important not to introduce too much of a attack surface, right?
Mm-hmm.
Would you think that in this case the extra attack surface outweighs the security benefit from it?
I think this is a really good question. I think the attack surface here has not been researched yet, and there is a lot of potential in it. So yes, I do think that this is better. This is a better path to take to see this, to research these tools, these attackers. Sorry. Any other question? Okay.
I don't see any, so applause, Omer.
Thank you.
Please rate the lecture at Inventory App, and since it was the last lecture in this track, feel free to go explore